right, let's talk about something that pretty much all of us have gone through at some point. Standardized testing. We're going to dive into the really complex world of test fairness, what bias actually means, and a pretty cool concept called universal design.
I mean, who hasn't, right? You get that feeling in your gut that a question was just designed to trick you, or that the whole test somehow missed the point of what you really know. Well, that exact worry, that's what we're going to unpack today.
So let's get to the bottom of that feeling. To really do that, we first have to understand what experts are talking about when they say a test has bias. It's way more specific and, technical than you might think.
Okay, so here's the official definition. See, bias isn't just about a test being difficult. It's when a test is set up in a way that it systematically gives different results for different groups of people, for reasons that have absolutely nothing to do with what the test is supposed to be measuring in the first place.
This really breaks it down. For a test to be truly biased, two things have to be happening. First, there has to be a score gap between groups, let's say men and women. But here's the second part, and this is the absolute key. That score difference cannot be because of a real difference in the skill being tested. So if the scores are different, but the actual underlying ability is the same, that's when you've got a bias test. And this is such a critical distinction to make, the difference between test bias and test fairness. Bias, that's a technical, statistical problem. It's something we can actually measure. But fairness? Oh, that's a much bigger, more complicated question. It's about our values. You could have a perfectly unbiased test that's still used in a way that society considers totally unfair. So, if that's what bias is, how do you even find it? Well, it turns out test makers have become detectives in a way, and their methods for hunting down this hidden bias have gotten way more sophisticated over the years.
The first and most obvious way to look for bias was just, to look at the final scores. If Group A scores lower than Group B on a math test, you might just go, aha, bias. But it turns out there's a huge problem with that simple logic.
And this quote just nails it. What if that score gap is actually reflecting a real difference in, say, knowledge or preparation between the groups? Just seeing a difference in scores doesn't automatically prove the test itself is the problem. It just tells us we need to dig a whole lot deeper.
Right, so since just looking at the final scores wasn't going to cut it, experts took the next logical step. They started looking at the actual questions themselves, hunting for bias on the face of things.
And this is where it gets really real. Are the pictures in the test only showing one group of people? Is the language in a reading passage full of stereotypes? Does the question assume everyone has had a certain kind of middle-class life experience? The classic example is a vocabulary question that assumes every kid knows a saucer is what goes with a cup. If you're a kid who's never used one, that's not a test of your vocabulary. It's a test of your cultural background. But now we get to the really clever stuff. The cutting-edge tool is statistical, and it's called differential item functioning, or DIF for short. And with this method, you can zoom in and analyze bias one single question at a time. So here's how it works, and it's brilliant. Imagine you take two people, say from two different demographic groups, but they have the exact same total score on a science test. So for all intents and purposes, we can say they have the same overall science ability. Now, if those two people still perform differently on one specific question, that question is a giant red flag. It's almost certainly measuring something other than science ability, and that means it's biased. Okay, so we're getting pretty good at finding bias, but just finding it isn't enough, right? How do you actually get rid of it? This is where the story shifts from just finding problems to actually building solutions, and it's based on a really elegant idea.
I love this little riddle. It seems like it's coming totally out of left field, but the answer connects everything we've been talking about. So think about it for a second. When are a building and a test the same thing? The answer is accessibility. Just like you want a public building to be accessible to someone in a wheelchair, you want a test to be accessible to every single person taking it, no matter their background or their abilities.
And that brings us right to this powerful concept, universal design. The whole point isn't to create a bunch of different tests for different people. The goal is to create one single, masterfully designed test that is just more accurate and more valid for everybody, period.
The wheelchair ramp is the perfect way to think about this. A ramp is absolutely essential for someone who uses a wheelchair, right? But who else uses it? Parents pushing strollers, delivery people with heavy carts, someone on crutches, shoot, even you at the end of a long day when taking the stairs just feels like climbing a mountain. A feature that was designed for one group's accessibility ends up making the building better for everyone. Universal design is just applying that same amazing logic to testing.
So what does this universal solution actually look like when you're making a test? Let's break down the real, practical principles that test makers can use to build a better, more accessible test right from the very beginning.
It all starts with the content, with the words themselves. You have to design for shared knowledge, avoid those cup and saucer type problems. You use simple language and short sentences. One expert said the goal should be to write for the youngest person taking the test, because nobody in the history of the world has ever complained that a question was too easy to understand.
And it's not just about the words. The physical layout of the test can make a huge difference. These little details, like using larger fonts, having lots of white space so the page doesn't feel cluttered, even using non-glossy paper to cut down on glare, they might seem small, but they reduce the mental friction for everyone. It's all about removing those unnecessary hurdles so the test can just measure what it's supposed to measure.
And really, that's the ultimate point. Universal design isn't about slapping on special accommodations at the end. It's a whole philosophy. It's about designing for maximum accessibility from the very start. And when you do that, you don't just get a test that's fair, you get a single test that is just fundamentally better and more accurate for every single person who takes it. Which leaves us with this one last really big question to chew on. After all this, with everything we know about hunting for bias and designing better tests, is a truly 100% culturally fair test of anything even possible? It's a huge challenge, and one that educators and test makers and really all of us are still grappling with.